Hello, it's the last online again, and you will be with Kimati, and we'll be discussing trigonometry, and by subtopic will be the inverse of trigonometric functions. So please be with me as I start up to an end of the session, so that you have a good revision of what we are going to do. Welcome. So today we will cover the following. First of all, we shall find the inverse of trigonometric functions, and then we shall see, or we shall revise on the graphs of trigonometric functions and their inverses. I will explain some few of them. I will show you the graphs of few of the trigonometric functions, and their inverses, so that you can have a revision to that. And then after that, we shall see on how we can prove expressions involving trigonometric inverse of trigonometric functions. And then after that, we shall solve some problems involving the inverse of trigonometric function. And then later on, I will leave you some few questions for you to practice. But as you know that there are a lot of questions you can do on your own out there. So please, you are welcome. Now, the inverse of trigonometrical functions. Trigonometrical inverses are sometimes called arc functions or sometimes ant-trigonometric functions. For example, we have a sine inverse. It is referred to be as sine raised to -1 of x, or arc sine x. So if you put a word arc, that means that raised to -1 goes, and then you are left with arc sine of x. So as to tan, so as to cos, to whatever. Also, we have a sec inverse of x, is sometimes known as arc sec of x. So if you put the word arc, that means that negative sign, -1 goes with. So we are left with arc sec of x. Or sometimes they are known as anti-trigonometric functions. So if you see these two words, don't be confused. They just represent the inverse of the trigonometric signs, trigonometric functions. For example, you can have, let's say, tan inverse of x. As I said there, this can be written as arc tan x. These two words are synonymous. These two words are the same. Or you can have, let's say, cosec inverse of x. This is arc cosec of x. It's the same. So these two words are very, very synonymous. Don't confuse. It's just the same thing. Now from there, let's see the graphs of trigonometrical inverses. For example, here we have a sine graph, a graph of sine function, a graph of sine function. The left one represents the graph of sine x. So it goes like that. I know you know how it goes. And on the right hand side, we have the inverse of sine x. So the graph of the inverse of sine x, it looks like that. It looks like that. This is how they look like. But also we have the graph of tan. This is the graph of tan. F of x is equal to tan, let's say, tan of x. So this could be the graph. This could be the graph. But also on the right hand side, we have the graph of the inverse of tan. That means this is the graph of tan inverse of x. This is the graph of tan inverse of x. This is how they look like. I do hope you see the differences. Let's see another example. We have the graph of sec. This is the graph of sec. It looks like this. That means it's the reciprocal of cos, the graph of cos. It looks like this. And this is the graph of the inverse of sec. That means this is sec inverse of x. If this was sec x, then this could be the graph of sec inverse of x. So there are a lot of graphs there. We have a graph of cosec, graph of whatever, a trigonometric function, but they do look different once you try to take the original graph and its inverse. They do look a little kind of different. So you can try on your own and use different applications to sketch those graphs, and you will see the difference. Now let's see the basic relationships. Let's see the basic relationships. We have, let's say, cosec of x is equal to sine inverse of 1 over x. Someone can ask you, can you prove that? Can you show that? We shall show it shortly. And we have sec inverse of x. is equal to cos inverse of 1 over x. Can you show that? Also, we have cot inverse of x is equal to tan inverse of 1 over x. Can you show that? And so forth, and so forth, and so forth. There are a lot of these. So, can you show them? Now, let's I will show the second one. I will show the second one. Sec inverse of x is equal to cos inverse of 1 of x. Let's say you are asked to show this. Show that this is equal to that. How can you do that? This is equal to that. How can you do that? It's simple. It's simple. Let's say, let me take this side from left hand side. We have, let's say I will let y is equal to sec inverse of x. We can say sec of y is equal to x. But we know what is sec. Sec is the reciprocal of cos of y, which equals to x. That means we can put it like this, 1 over x equals to cos y. That means we have made the cos of y the subject of our formula. That is to say, the value of y is equal to what? Y is equal to cos inverse of 1 over x. And you will see that the result that we have obtained there is equal to the result that at the right hand side of that. That is to say, sec, in the question of showing, I told you last time, remember to conclude. That is to say, left hand side is equal to right hand side. That is to say, sec inverse of x is equal to cos inverse of 1 of x. This is very useful while trying to do a lot of different questions involving trigonometric inverses in integration and whatever. Now, let's check the other examples. I hope you will show the other examples by the use of the same procedures. You will use them to prove or to show these different expression or relationships. I do hope you will enjoy that. Now, let's see some few examples on how we can simplify, and then we shall show, and then we shall solve and evaluate different. Now let's see the example number 1. Let's see example number 1. That tells us to simplify. That tells us to simplify. And we are told to simplify what? We are told to simplify tan inverse of x plus tan inverse of 1 minus x over 1 plus x. So we've been given such a thing, and we are told to simplify. That means we are supposed to use different rules that involve the use of these angles. It can be double angle formula, it can be half angle formula, whatever rule that you can use, so as you can simplify that by the use of the rules. Now let's see how can we do this. For example, the solution to this, I will use the following method. For example, I will say let's say a equals to this thing here, so it will be tan inverse of x. It implies that tan of a is equal to x. I do hope you agree with me. And we have let b and b equals to tan inverse of 1 minus x 1 plus x. That is to say, tan of b equals to 1 minus x 1 plus x. 1 minus x 1 plus x. And then after that, can we use the following? Can we say a plus b, let's say, is equal to c? Because we had the summation to this, the sum to this. This I called it a, and that is b. That is to say, I'm trying to add a to b. Then my sum will be c. That is what I'm trying to do. Then after that, I will open both sides by the use of tan. So can I write the following? That can I say c is equal to a plus b? It's just the same. Then I will open both sides by the use of tan. That will be tan of c equals to tan of a plus b. That is to say, the answer that I will obtain it here, I will find its inverse, and then after that, the c will be my simplification to that that expression that have been given there. So how will it be? That is to say, let's open this by the use of double angle formula. It will be tan of A, tan of B, as we discussed earlier, is 1 minus tan of A, tan of B. And then this is equal to tan C. So in the place where there is tan A, I will put the value of tan A. And in the place where it is tan B, then I will put the value of tan B. So let's see how are we going to do that. Let's see how are we going to do that. So we're going to have tan of C and then tan of A, which is x, plus tan of B, which is 1 minus x, 1 minus x over 1 plus x. Most of the students do try to confuse when they see this line here and then they have that thing there. I advise you to use this method. It's quite the same. Just write like that. Then we have 1 minus tan of A, tan of B. Then how can we do that? Then we have 1 minus tan of A is x, and this is multiplied by tan of B, that is 1 minus x, 1 plus x, and all of that is divided to that thing. So let's simplify that. Okay, this can be multiplied there, so it will be 1 plus x plus 1 minus x, 1 plus x, and all of that is divided to what? This can be multiplied there, it will be 1 plus x minus x, 1 minus x, and all of that is divided to 1 plus x. 1 plus x. So how can we do that? Now let's open the brackets. There it will be, we have x plus x square, then plus 1 minus x, and all of this is 1 plus x over 1 plus x. Then divide by what? By 1 plus x minus x plus x square over 1 plus x. And then let's simplify that. That means we have this and that. This is positive and that is negative. That means this and that goes. And then we are left with x square plus 1, 1 plus x, divide by, and then on that side we have this and that goes, and then we have what? We have 1 plus x square over 1 plus x. And then after that, let's divide that. That means we have x square plus 1, 1 plus x. All of this is multiplied by 1 plus x, 1 plus x square. So if you try to look that much careful, you see these two things are reciprocal to each other. That means this is the reciprocal of that. That is to say, this and that can go, this and that can go. That is to say, we have 1 and this equals to tan C. And what is C? That is to say, we have tan inverse of 1. And tan inverse of 1, we know that it is pi over 4. That means it is 45. That is to say, all of this is equal to pi over 4. That is 45. So this is how we simplify that simple expression like that. Just follow the rules and things will be very much okay. So remember to conclude. I will conclude it here. I'll conclude it here. Then I will say tan inverse of x plus tan inverse of 1 minus x 1 plus x is equal to pi over 4. This is your conclusion. Thank you very much. I do hope you understand that. So don't forget to conclude. Remember to conclude. Now, from having that knowledge, or from having that reminder to ourselves, let's try to do the next example. That says if tan inverse of A plus tan inverse of B plus tan inverse of C is equal to pi, then we are supposed to show that A plus B plus C is equal to 1. A plus B, if tan inverse of A plus tan inverse of B plus tan inverse of C is equal to pi, then we are supposed to show that A plus B plus C over ABC is equal to 1. Can we do that? Yes, it's fairly simple. We'll let this, and then we'll open the brackets, and then I think things will be very much okay. Let's see how it is done. So we are told to do that. We have tan inverse of A, tan inverse of B plus tan inverse of C equals to pi. And what are we supposed to do? We are supposed to show that A plus B plus C over ABC is equal to 1. So this is what is required. This is what is required. So let's see how can we do that. Let's see how can we do that. Now, I will let my solution, we'll start with let's say A equals to capital A equals to tan inverse of A. That is to say, tan of A is equal to A. And B equals to tan inverse of B. That implies that tan B equals to small case b. And then we have C, that is tan inverse of C. That is to say, tan of capital C is equal to small c. Okay. Then after that, all of these were added. All of these were added. That means that to that to that. And then the answer was pi. So let's see. That means we have A plus B plus C, and our answer is supposed to be pi. Our answer is supposed to be pi. And if you try to look that much careful, it can be a tan definition. So let's open this by the use of tan. As I explained last time, and I left for you a question that you are supposed to find the compound formula for A plus B when you open it by tan, then I left that question to you. Now let's do it together. Now let's open, or let's do this on both sides. That will be tan. Let's apply tan on both sides. Plus C equals to tan of pi. Tan of pi. We know that tan of pi is equal to 0. That is tan of 180 is equal to 0. We know that. But what about this side? What about this side? So we have to work this side so that we can, this thing can happen here. Now, it just won't come by itself. Now, let's do it. Now, I will take B and C and use capital X to denote that. That means instead of having tan A plus B plus C, I will have tan A plus X. And X denotes B plus C. And that is to say, we are going to be left with A plus capital X. That is equal to tan of that side. We know it's 0. That is tan of pi. Now let's open this. This is more simple. Let's open this. How will it look like? It will be tan of A plus tan of X over 1 minus tan of A tan of X. But remember, we don't have X there. We have B plus C. That is to say, we are supposed to open that also by the use of A plus B. That is to say, this is equal to 0 as it is in that. That is to say, we are going to have tan of A plus tan of B plus C, plus C over 1 minus tan of A tan of B plus C, and all of this is equal to 0. and all of that equals to 0. So can we open that? It's fairly simple and very, very easy. Let's open that. So we have tan of A, as it is there, plus, be careful there, tan of B, tan of C, 1 minus tan of B, tan of C. But also we have this thing down here. So we are going to have 1 minus tan of A, then multiplied by what? Something like this, over 1 minus all of this, we are told that is equal to 0. So let's use that. Let's use that. But we know that tan of A is equal to A, tan of B is equal to B, and tan of C is equal to C. Can we plug those there? Let's do it. You can simplify it first, or you can just plug and then simplify. They all look alike, and they all look the same. That means tan of A is A, plus tan of B is B, tan of C is small c, and there we have 1 minus BC. All of that is in brackets. Then we have 1 minus tan of A is A, and then there we have B plus C, 1 minus BC. And all of that we are told is equal to 0. Okay, can we simplify that once more? Let's remove this and let's see what will happen. Let's open that. That is to say, we shall have A in brackets, we shall multiply with that. It will be 1 minus BC plus B plus C, and then all of this is over 1 minus BC. Then all of that is divided to what? To 1. And this is multiplied by, if we open the brackets, then this will be multiplied by 1 minus BC minus A. If you multiply A and B, it will be AB. Then minus that, it will be AC. And all of that is over 1 minus BC. And all of this we are told is equal to 0. So how are we going to do that? You will see that, as we did in previous example, this and that are the same. That means once we do change, or we do divide, that means this and that will go. So we'll be left with what? We'll be left with A, 1 minus BC plus B plus C. Then down here we'll be left with 1 minus BC minus AB minus AC equal to 0. So let's open that. Let's open those brackets and see what will happen. There we have A, and then we shall have minus ABC plus B plus C over 1 minus BC minus AB minus AC, and we are told that this equals to 0. That equals to 0. Now, if that equals to 0, what can we do next? You will see that this part here can be multiplied by 0 and the answer will be 0. And that is to say, we will be left with A minus B. Oh, I can arrange this alphabetically. Then minus A, B, C, equals to 0. Then can we take ABC on that side, or can we add ABC on both the sides? That is the same language. Equals to ABC. And then after that, can we divide by ABC throughout? Then if we divide by ABC throughout, that is to say by ABC, and there by ABC, what are we going to be left with? That side will be equal to 1, and then we shall have A plus B plus C over ABC equals to 1. And you will see that we have obtained the thing that was required to prove, to show that we were told that if tan inverse of A plus tan inverse of B plus tan inverse of C is equal to pi, then we were required to show A plus B plus C over ABC is equal to 1. As you can see here, the procedure shows that this is quite the same. That is quite the same. As I did to remind you, this was a tricky part. I could not open the 3 by 3. Then I did let B plus C equals to X, so that I could have a 2A plus B, A plus X, that could be a compound angle, and then opening that, I ended up having that thing, and then I tried to put back that was BC there, and then opened, and then it was fairly simple. Just be careful on your steps, and I assure you, you will reach the conclusion. That is very, very, very easy. Now let's see the next example. Let's see the next example. Okay, now the third example, as we saw in the last example, it was fairly easy. Let's see the next example. That is, suppose it tells us, or it wants us to solve. That means the value of x, as we can see, the variable there is x of what? 2 tan inverse of x minus 1 minus x over 1 plus x. All of that is inside the bracket is equal to tan inverse of x. We're supposed to solve. That means we are supposed to find the value of x in that thing. We're supposed to find the value of x. How can we do that? Let's check it out. Let's check it out. So we have 2 tan inverse of 1 minus x 1 plus x equals to tan inverse of x. So what is required there? We are required to find the value of x. We are required to find the value of x. That we are supposed to solve that. We are supposed to solve that equation. Now, how can we solve this? It's fairly easy. Let's say, can we let, yes, solution. Let's use capital X equals to tan inverse of what? Tan inverse of 1 minus x 1 plus x. That is to say, tan of capital X equals to 1 minus small x 1 plus x. And what about the other side? Let's say capital Y, and y is equal to tan inverse of x. That is to say, tan of capital is equal to x. Is equal to x. Now, what can we do from there? What can we do from there? We have tan of y and we have tan of x. Tan of y and tan of x. But remember, there you have a 2. There you have a 2. That is to say, you can say, you can have the following. The value of tan capital X and tan capital Y. How can we do that? Let's see. From the equation we have 2, but we do let this equal to y, and that equals to, this was x, sorry. This was capital X and that was y. And then after that, what can we do from there? Let's open this. Or let's apply tan on both sides. That will be tan of 2x equals to tan of y. And if that is the case, we know how to open this. This is by double angle formula. You know, it will be 2 tan of x over 1 minus tan square of x equals to tan of y. But we know the values of this. We know the value of tan x, which is that. And also we know the value of tan y, which is that. So can we plug them there and see what will happen? Let's check it. Let's check it. So we'll have, from this side we shall have 2, but our tan of x is this thing here. So we are going to be left with 1 minus x 1 plus x over 1 minus tan x square, or tan square of x, tan square of x, sorry, tan square of x. And what is that? Tan square of x is this thing here. So we are going to be left with 1 minus x 1 plus x, and all of that is squared and is equal to what? Tan of y, which is x. Which is x. Now, what we are left with is to simplify this so that we can have a much more simple expression, and then after that we find the value of x. We find the value of x. And how do we do that? Let's do it. And how do we do it? Now let's multiply this on that side, and then we shall, okay. Now it will be 2 1 minus x 1 plus x equals to what? To x. And then we have 1 minus, in brackets, we have 1 minus x 1 plus x squared. So what can we do from there? That is to say, we are going to be left with 2 minus 2x over 1 plus x equals to, let's open that side, and we know that we'll be left with x, and that will be what? Let me write it in a much more simple way. 1 minus x, that is squared, and down here is 1 plus x, that is squared. Don't look shy or don't see yourself, you don't know mathematics by doing that, because it's much more safe for you. So here we have 2 minus 2x 1 plus x equals to, let's open that side. That means we are going to be left with x, and then if you add this, then it will be 1 plus x, that is squared, minus 1 minus x, and that is squared too, then over 1 plus x square. As you can see there, this factor, it just repeats itself here. That means we can take, simplify this by taking this to that. That is to say, we are going to be left with 2 minus 2x is equal to what? Is equal to x 1 plus x, and that is squared, 1 minus x, and that is squared too. But all of this is over 1 plus x. 1 plus x, because 1 and 1 from there goes. That is to say, this multiplying to that side, we are going to be left with 2x, and then times what? 1 plus x. 1 plus x equals to x. Let's open the brackets there. And if you open that much careful there, you will see that you are going to be left with what? 1 plus 2x plus x square minus 1 minus 2x plus x square. So how can we simplify that? Can we open it here? Then if you open it there, that means there will be a negative, and then there will be a positive, and then there will be a negative. That is how it will look like. That is to say, this one and the what one there will go, and then what again will go? This one and that one also will go. Then we'll be left with the 2 and 2 will be 4x, and all of that is multiplied by 4 by x square. That is to say, on this side, for example, there we can put 2 like that. Then we shall have 1 minus x, 1 plus x equals to x times 4x. It is 4x square. If you try to open that, you will see that it is 2. Then we have 1, we have x, we have x, we have minus x square. That means the difference of 2 squares equals to what? Equals to 4x square. This and that will go. That is to say 2, 1 minus x square equals to 4x square. Then there we have 2 minus 2x square equals to 4x square. Then we have 2, which equals to this, going to that side, it will be 6x square. So if we try to put that much in a good manner, that it means it will be 3x square equals to 1. And how can we simplify that once more? That is to say, we have x square equals to 1 over 3. But in our question, we are not asked to find the value of x square. We are supposed to find the value of x. That means we are supposed to find the square root of that. That is to say, on that side is in that way, and then on that side too, plus or minus 1 over 3. That is to say, on this side we are going to be left with that, and on that side it will be 1 over plus or minus and out 3. Please rationalize that. It will be what? X equals to, I'm multiplying that to that side. That means you have supposed to multiply by and out 3 and out 3. Then you will be left with and out 3 over 3, that is plus or minus. And a valid answer here is x is equal to and out 3 over 3. This is the value of x, my dear student. This is the value of x, my dear student. So please just follow the rules, and step by step, I assure you, you will end up having a correct answer. You will end up having the correct answer. And most of the students try to confuse, especially in doing this arithmetic here, this part, dividing this to that, this to that. Just go step by step. Just go step by step, and I assure you, you won't miss an answer. You won't miss an answer, because if you multiply that, sometimes you can forget a negative or whatever. Just be careful and do that arithmetic very careful, and I assure you, the answer is your reward. The good answer is your reward. So please just practice, and after I'm done with this question, just try to do it by yourself. As you are trying to watch this, just copy it outside and try to do it by yourself without looking of what I was doing here. Because once I'm solving, you will see that you have understood very much correct, but on yourself, you will fail to do this if you don't practice. So please practice. Now, let's see the example number 4. We have been told to evaluate. We have been told to evaluate cos, in brackets 2, tan inverse of negative 3 over 4. We have been told to evaluate that. That means we are supposed to find the value of this. We are supposed to find the value of this. That's why we have been told to evaluate. Now, how can we do that? Let's check it. It's very easy. So we have cos of 2 tan inverse of negative 3 over 4. So we are supposed to evaluate that. We are supposed to evaluate that by the use of the inverse of trigonometrical functions. Now, how can we do that? How can we do that? The trick here is to take this thing here and put it aside. That means we can say, we can let that equals to alpha. Let alpha equals to what? Equals to tan inverse of negative 3/4. That is to say, tan of alpha is equal to negative 3/4. Oh, okay. If that is the case, that is to say, if that is the case, let's go there. That will be alpha, but multiplied by 2, and then outside is opened by cos. That means you are supposed to find the value of this, because alpha is the tan inverse of that. That means we can open that. But we know that this, opening this by the formulas, we know that it is cos of alpha plus cos, we know it is cos of alpha plus alpha, which equals what? Cos alpha minus sin alpha sin alpha. And we know better than that. That this equals to what? This equals to cos square of alpha minus sin square of alpha. Now, what are these? So this is cos of 2 alpha. Now, what are these? Where do we find the values of this? That means we are supposed to find the value of cos alpha and then sin alpha. Now, where are we going to get those? Let's use this. Let's use this part. Now, from that part, let's have the xy plane. The xy plane. And this xy plane will have the following. And this will be the y-axis, as you know. And that will be the x-axis. Or sometimes referred to be y is equal to 0, and that is x is equal to 0. Now, let's have this. We know that if we have tan of alpha, which is negative 3/4, negative 3/4, that is to say, we know that tan is equal to opposite over adjacent. We know that. And that means this is the opposite and that is the adjacent. That is to say, if the opposite is negative, that means we are going that side. That means we are going on that side. That means it is negative. It is negative on that direction. And if the adjacent is 4 positive, that means it is in that direction. That is to say, if that will be 4 and that is negative 3, our point could be somewhere there, and we can have something like that. And our angle is always in reference to x-axis, a positive x-axis. That is to say, it will be there. And this point will be negative, will be 4, negative 3. That is to say, having a right-angled triangle there, that is what will look like. That's what will look like. And this, the value of there is negative 3, and that is 4. And that negative just denotes the direction of that distance. It is a negative direction to x, to y. That means it's going downward. Now, can we find the hypotenuse so that we can have the value of cos alpha and the value of sin alpha? Can we do that? And it is very easy. It's very easy. That means by the Pythagoras theorem, we know that if this is side A, that is B, and that is C, that is to say C square is equal to A square plus B square, that is C square is equal to A square, is negative 3 square, that is 9, plus that side is 4 square, that is 16, that is 9 plus 16, that is 25, and that is C square, and the C equals to 5. We know that. That means C there equals to 5. From that part, my dear student, we can find the value of sin alpha and the value of cos alpha. And those, my dear, will be used there so as we can have the value of cos 2 alpha. Now let's find the value of cos alpha there. Now I'll write it there. Cos alpha, we know that cos is equal to adjacent over hypotenuse, and our adjacent there is 4 and hypotenuse is 5. What about sine alpha? Sine alpha equals to what? Sine, we know it's opposite over hypotenuse, that is negative 3 over 5. So can we use those values to find the value of cos 2 alpha? Yes, it is very, very, very possible and very, very nice to do. Now, there we have a cos of x, a cos of alpha. There we have a cos of alpha. Now, cos of alpha, it is 4 over 5, and all of that is squared, minus what? Sine of alpha, which is negative 3 over 5 square, which is negative 3 over 5. So how can we do that? It's very, very easy. There mathematics is very, very done. So we have, there it will be 16 over 25 minus, and this is cos 2 alpha, minus 9 over 25, and doing that mathematics there is 7 over 25. That is cos 2 alpha. And what is our alpha? Remember, we let the alpha. That is to say we have cos of 2 alpha was tan inverse of what? Negative 3 over 4, and at the end we have obtained the value that is 7 over 25. So that is how we evaluate such kind of the expression, as we are told to evaluate that. Now, my dear student, please do some practice. Do some practice, not some, a lot of practice. Because mathematics without practice is like a language that you don't speak, and then you will never understand and never know how to speak it. Now, I will leave you some few questions, and the questions for more practice, they are very easy actually. You find tan inverse of under root 3 plus cot inverse of x, that equals to pi over 2, and then you are supposed to find the value of x. So the question is like that. That is to say, you can just let this, and then remember that cot is the reciprocal of tan. Remember that cot is the reciprocal of tan, and then do that, and I assure you get the answer. And then find the value of the last expression that I was evaluating was like this. So please find a way to do this so that you can have the value of that. Also, there is another question here. Show that tan of a half sine inverse of that thing is equal to that thing. So please, it's very easy. Just do practice and try to do these questions and copy it out there and solve them, and make sure you get the answers. Make sure, because all of these questions have answers, right? And before I plugged them there, I also did them, so I know they have answers. So please, try to make sure you obtain the right answers. For example, there you have an answer. So if you don't get this thing, that means you are wrong. So make sure you get that expression there. Also, we have tan inverse of x plus 2x plus 1 minus tan inverse of 2x minus 1 is equal to tan inverse of 1 over 8. Fairly easy. Make sure you do it. Make sure you do it and find the answers to that. And I assure you, if you do these questions and a lot other equation, you have reviews and other books to have questions from there. So if you find those questions and do them and make sure you get the right answers, I assure you, success is on your way. Success is on your way. So all the best. Have a nice time out there. Stay safe. Stay at home. And please remember, you are still students. Bye-bye.